Welcome to McPlum, simple solutions served daily.
You begin by collecting the minimum required inputs so calculations run cleanly. Enter the fluid, its phase, and the working temperature range. These set property lookups. Next, record geometry, pipe diameter, plate length, fin spacing, and orientation because conduction paths change with direction. Finally, measure or estimate flow speed so you can compute Reynolds number. Once done, use the book's property tables and correlations immediately. This gets you into analysis instead of setup and prevents backtracking later. You now convert inputs into usable coefficients. Start by interpolating thermal conductivity, viscosity, and density at the mean film temperature so property values match conditions. Then calculate Reynolds, Prandtl, and if natural convection applies, Grashof numbers to classify the regime. Once you have non-dimensional numbers, choose the appropriate correlation in the book, Dittus-Boelter for turbulent internal flow, Churchill-Bernstein for external spheres, and so on, because the right correlation controls accuracy. Make sure to check validity ranges before applying any formula. You finish by calculating H or overall U using the chosen correlation and the interpolated properties, then solve for heat load or temperature change as required. After that, perform a unit consistency check, and if properties vary with temperature, iterate using updated mean temperatures until values converge. If numbers deviate from expected empirical ranges, revisit correlation choice or refine geometry inputs. One key troubleshooting tip: when results look unreasonable, recompute non-dimensional numbers and confirm you used the correlation valid range rather than forcing a convenient formula.
Thanks for watching. Stay juicy and subscribe.